At the end of the previous video, I mentioned that it really did not hurt to put those quantile functions within our if-else statement because someone had vectorized the if-else statement. Let me talk now about what vectorization means. This is a funny sounding word, complicated sounding word. Sometimes actually creating vectorized functions can be complicated, but the bottom line is that we can use them very simply, and to get a basic sense of what this is all about is not that complicated either. Vectorization means that a function operates on a vector rather than a scalar. So the function is operating on many elements at once rather than a single element. Vectorizing is the process of changing a function to operate on a vector. Vectorized code is simple and inherent in R because it is a vector language. Now we will talk about loops in more detail in a later learning cycle, but most loops can be eliminated when code is vectorized. I'll show you what a loop means in just a moment here. Loops can really gum up the works and slow down the process, so being able to eliminate them by vectorizing code makes it worth it to vectorize the code. Vectorizing in R has major advantages: fewer lines of code, reduced need for manual creation and initiation of objects, and speed. Okay, so this is what vectorization is all about, but to really understand it, we're going to have to look at some examples. So look at this code chunk. What I've done in this code chunk is I've created a way to add up all the numbers in this vector. So I set a vector equal to x. Let's go ahead and clear our environment and run that. So here is x. Now this is simple. There's only 6 of them. But imagine if there were 600 or 6,000 or 60,000. So here is the way to do this via brute force, to manually add these all up. I'm going to create this new object that I'm going to call sum of x, and I'm going to set it to 0. And now I'm going to do this thing that you don't know how to do yet, unless you've been studying ahead or studied R in the past. You don't have to know how to do it now because I'm going to tell you what it does, and in a later learning cycle, you'll learn how to do it. But this is referred to as a for loop. What this is going to do is it's going to take whatever we have as the sum of x, remember that's 0, and it's going to add to that the first element in our vector, 5. Then it's going to loop around and do it again, and it will add 11 to that 5. That will give us 16. Then it will loop around and add the 19 to the 16, and it will keep doing it over and over until the vector's done, which in this case means it only needs to loop 6 times, but it could need to loop 6,000 times if you had a vector of length 6,000. So let me go ahead and run that. And what I end up with after I've done this is I end up with a sum of x of 76. So I was able to sum up all the elements of that vector. Now that's the way we would do this with most computer languages, yet R is a vectorized language because the statisticians who wrote R know that in statistics we work with vectors. So we can do it like this. Here is the sum of x as a function, and it's a vectorized function, meaning that it's not going to loop through these. There is a vectorized addition. And so we can get the sum of x, which I've done now here, 76, without having any loops. So I've eliminated this loop with this function that is written to be vectorized. That is, if you put in a vector and say sum, you don't have to do it one element at a time. The sum function has been vectorized, so you can put a vector in there and it will go ahead and sum everything in that vector. Most of the functions that we deal with in R on a regular basis are vectorized, meaning that they will operate on a vector. We don't have to give them just one or two numbers. We don't have to give two numbers here to sum. We can sum them all at once. Here's another example. We're going to obtain 500,000 random numbers for each of the two variables. Now I'm beginning by setting here a sample size, n, to 500,000. This is good practice because if I want to come and try this again with 1,000,000, I can change it up here instead of changing it all the way through my code. In fact, I could have also set the mean and standard deviation, which is what the 50 and 10 are. I could have also put those up here as objects for the mean and standard deviation so that I could have changed the sample size, the mean, the standard deviation. Right here, all I did was put in the sample size. Now, this function here takes a random sample of however many I ask for. In this case, I'm going to ask for 500,000 from a normal distribution. R norm means random normal. From a normal distribution with a mean with this middle argument here, 50, and a standard deviation with this last argument here of 10. So I'm taking two random samples here. Both of them size 500,000, and both of them from a normal distribution with a mean of 50 and a standard deviation of 10. And then I'm going to put them in a data frame. So I'm going to have two variables, x1 and x2. Those will be my two columns in the data frame, which I'll call random data. Okay, let's run this. Now I have it. If we look here, we see random data, 500,000 observations of two variables. That's in our data frame. If I open this little blue arrow, it'll tell us they're x1 and x2, and we'll see the first few numbers for each of those. So we now have 500,000 pairs, x1, x2 pairs of data. Each pair is in a row in our data frame. Let's calculate the mean for each pair. Let's keep track of the time it takes to do that. So here's what I'm going to do. I'm going to set these row means variable. So here I'm going to loop through 500,000 times, one time for each pair. I'll take the mean of x1 with x2 for the first row, and then I'll loop through and do it for the second row and the next row and the next row. And the whole while, I'm going to save all those row means so that I end up with 500,000 means, where each mean is the mean of x1 and x2 for that row. But I'm going to do something else, a little bit fun. I'm going to keep track of the time it takes to do this. So I'm going to use a function, systime, that will actually take the time off my computer's clock. And then I'm going to do it again at the end, and we'll be able to see how long it took by comparing the difference in those two times. All right, here we go. You ready? Here we go. All right, it's working. Now there's a couple things to show you. Notice that this is red, this chunk icon. Notice up here the little stop sign. And notice in the console window we have no prompt. What does that mean? Does that mean things blew up? No. In fact, we can see now we have a prompt, the stop sign is done, and the code chunk is back here to normal. It means that this was running, and it was asking us to wait while it ran. So, let's look at the first 10 means that we have. Here they are, the first 10 means of those rows, and let's see how long that took. It took 14.8 seconds. Now, it'll be interesting to see how long your computers take. We should compare ours to see who has the fastest computer on the block. Okay, fun fact. Someone has written a vectorized function to obtain the mean of each row. Let's try it and time it. I'm going to clear the environment. We're going to go ahead and start from scratch. Environment cleared. I'm going to go ahead and get random numbers again. Still 500,000. I'm not cheating. Here they are, 500,000. And now we're ready. And so look what I'm doing this time. No loop. I'm using a vectorized function called row means. This is actually going to get us a row mean and vectorize it across all of our observations. So we'll have all row means. Let's go for it. Ready? Here we go. Get ready to watch for that stop sign. Oop, I didn't see it. Did you? No. It happened so quickly. Here are the first 10 row means. If you look over here, row means, it said there's 500,000 of them, so it did all of them. We're looking only at the first 10. How long did that take? 0.026 seconds. 0.026 seconds compared to, what did I have before? It was, where is it up here? I think it was, here it is, 14.8 seconds. So as you can see, vectorization made the code so much easier. We had this loop in here before in order to loop. And down here, we have just one line with one function. It's a vectorized function. So get used to the fact that when you're working in R, that it is set up primarily to work with vectors, not scalars. We have seen that vector is the smallest unit. It is the base unit. Whenever you do things like, for instance, multiply a vector by a number, it multiplies every element of the vector because that multiplication operator has been vectorized. Most everything, except for what we write new as our own functions, most everything that's already written has been vectorized. And when we write our functions, we'll do the best we can to keep things vectorized as well.